The first step in sketching the curve of a given function is by identifying the critical points. These are the highest or the lowest points in the curve. Learn how this is done here in differential calculus. How do we look for the critical points? Having a given function, take the derivative in order to have the slope. And from the highest or lowest points, the slope is 0. Equating the first derivative to 0, we can look for x. So to complete the critical point, substitute x into the original function to have y. Learning about the critical point, next is to categorize if it is the maximum or the minimum point. That is by looking for the second derivative of y, and then check if y double prime is negative or positive. If it is negative, the critical point is a maxima, or the highest point. And if y double prime is positive, then the critical point is the lowest, or the minima. The first example is a short one. The function is y as equated to 4x squared plus 16 of x plus 9. And we are to locate the critical point and identify if it is a maxima or a minima. To locate the critical points, we start by taking the derivative of the function. Since there are multiple simple terms, we separate them to easily differentiate. The last term, which is derivative of 9, can be zeroed out. So y prime is then the constant 4 times the derivative of x squared, which is 2x. Then through chain rule, there is also d of x with respect to dx. The derivative of 16x is then the constant 16 times the derivative of x upon x, which is 1. Dx over dx is 1. So, y prime is 8x plus 16. This is the general slope equation. To look for the critical point, zero out the slope, making 8x plus 16 as equated to 0. Transpose 16 to the other side and divide each term by 8 to have x as negative 2. Knowing the x-coordinate of the critical point, look for the y-coordinate by plugging negative 2 to the original function. Y then becomes 4 of the square of negative 2 plus 16 times negative 2 plus 9. Y is then negative 7. So the critical point is at negative 2, negative 7. The next thing to do is to identify if the critical point is the highest or the lowest point. This is identified by taking the second derivative. By taking d over dx of the first derivative, the last term, which is the derivative of 16, is then zeroed out. Y double prime is taken as 8. This is greater than 0. So the critical point located at negative 2, negative 7 is a minima, or the lowest point on the curve.